Hello everyone, welcome back to Study Crunch. Now this is the second lecture of digital signal processing. We are going to see problems on DFT now. The properties we studied in the earlier chapter, we are going to see or we are going to solve some numericals on that. Starting off with the first question. Okay, now just look at this question very carefully. It has two parts. Okay, so first is xn. We have 1 2 3 4. We have to find the DFT of it. Now we have to use the result of the DFT obtained from 1 2 3 4, and from the result obtained we have to solve these questions, right? Now let's see. First of all, the formula, that is x of k is equal to summation n is equal to 0 to n minus 1 x of n, where x of n is the given series, into e to the power minus j 2 pi k n by n, right? N is 4 in this case, capital N, because we have 4 number 1 2 3 and 4, so n is 4, capital N. Small n is equal to n minus 1, capital N minus 1. Small n is equal to n minus 1, so we have 4, 4 minus 1 is 3, so small n is 0 to 3. Now the value of k will be according to the numbers. Let's start. Okay, so for first x of k, we have x of 0 e to the power 0, because here we can say that j 2 pi k n by n becomes 0, because our n is 0. So when n is 0, it will become 0. E to the power 0, x1 e to the power 0, x2 e to the power 0, x3 e to the power 0. So it is 1 plus 2 plus 3 plus 4, that is 10. Right? Now x of 1, again x of 0 e to the power 2 pi j k n by n. So we have n as 1, 2, 3 and 4. For x1, x2, x3. So we have already done x0. Now it is for x1. So x1 will be, so here all n will be 1, and we'll be putting the value of x0, x1, x2 and x3. But this is a very long method, that is, it will consume a lot of time. So what we do is we take the matrix method. This is a shortcut of this method, right? So what we do is we have x of k, which is 1 into n or n into 1, then which is equal to the twiddle matrix, that is n into n, and we multiply it by x of n, which is again 1 into n or n into 1. Now let's see how we do it. Just remember this matrix for 4-point DFT. We put x is equal, k is equal to 0, k1, k2 and k3 in the rows section and n in the column section. So we have n is equal to 0, 1, 2, 3. Now x of k is equal to 1. Here it is also 1. Then we have minus j, minus j, minus j and minus j. Then there is a diagonal of minus 4 and then it is 1. So this is the easiest method to solve DFT. Just take this matrix and multiply it by the matrix that is given to you. So it is 1, 2, 3, 4. Only we have to multiply this matrix and we'll be getting the DFT, that is 4-point DFT of a signal. Now we have a DFT. We'll start off with the first question, that is 4123. So you can observe that if we have x 1 2 3 4 and we have x of 1, n is 4 1 2 3. So you can see that it is time shifted. So for time shift we can apply this property, that is n minus l. Why minus? Because it is shifted towards the right hand side, right? So when it is shifted, then we have x of n minus l, x of k minus, we take n minus k n. This is the term we take for apply this property. Then we have x of k as this was the answer. Now you just have to put the value of k 0. Again the value of k and n is changed. Then we have k is equal to 1, k is equal to 2, k is equal to 3. Putting the value of n as 1, n as 2, n as 3. You will be getting the answer. And this is the twiddle factor. We have W40, we have value 1. Then for W41, we have value of minus j, move it in clockwise direction. Then we have 43, it is minus 1, 4 4, that is j. Next, x2 is 2 3 4 1. Now this is shifted, that is it is advancement in the signal, right? So it is n plus l. So for n plus l we have to take k plus l by n. This was earlier taught. Then we have k is equal to 0. Only put the values and you will get the answer. You have to write the twiddle matrix values from here. And then solve for the questions. For the third part we have 3 4 1 2. Again it is shifted 2 times, then it was n minus 2. For n minus 2, this part is W4 2k. nk na. So we have n is equal to 2. Then again putting the value of 0, 1, 2 and 3. When we put the value, we can easily solve the question. Then is the fourth part, that is 4 6 4 6. Now there is no direct connection between both of these. But if we take xn, that was the main signal, that is 1 2 3 4, and we add the value, or we take this value 3 4 1 2, that is time delayed version of that is x of n minus 2, then we'll be getting 4 6 4 6. Now how to solve these types of questions? We have x of 4 as x of n plus x of n minus 2. Just write the DFT of this signal, that is omega n k l into xk. We have to solve this part and just put the values x0, x1, x2 like we solved. So we have to basically solve two DFT in this. That is first of all DFT for this and the second is DFT for this part. When we solve this question, that is x1, x2, x3, you can look out for the calculations. It's very easy. Just put the values of the signals of xn. So this was all about this lecture. I hope this is now clear. Next we'll be moving forward to convolution, that is linear and circular. If you have any doubt, you can always ask me in the comment section below. Thank you.